Good morning to all of you. I'm AJ. I will be presenting the results and key findings of our project in Mandaue City. Before we start our presentation, we would like to thank Fisher DOST for funding the study, and the fieldworks were done by UP Cebu with Mandaue LGU. The training and equipment were provided by UP Diliman, our lead team. First off, here are the topics to be discussed here. Let's start with a question. Have you ever wondered why urban cities are hotter than rural areas? This phenomenon is called urban heat island, or UHI, wherein cities have higher air temperatures and surface temperatures compared to the rural surroundings. That results into a lower thermal comfort of the urban residents. Mainit ang temperatura, so hindi komportable ang mga residente. Here are the causes of UHI. Reduced vegetation cover, increased impervious surface materials like concrete and asphalt, change in urban layout, anthropogenic sources like vehicle and industrial exhaust. Our study site is Mandaue City. It is recognized as the most industrialized city in Metro Cebu. It has a land area of 35 square kilometers compared to its neighbor Cebu City, which has a land area of 315 square kilometers. Despite of it being highly urbanized, it still has dense mangrove forests. Mandaue City LGU plans to protect and conserve this area. Mangroves, or vegetation in general, play a major role in mitigating UHI. This is how we studied and analyzed UHI in Mandaue City. First, we had field observations, which is going on site using measuring devices such as thermal sensors and PM sensors. Second, utilizing remote sensing data, specifically satellite data, Landsat 8. Lastly, using urban microclimate simulation to be able to study various scenarios and understand the mechanism behind UHIs. In this section, I will be discussing the results of our field observations. During field sampling, we measured LSTs on different materials using infrared thermometer. We tracked and marked sampling points using GPS and measure air quality parameters using a PM sensor. Here are the priority sites of our study. For priority site 1, we have 4 areas of interest. We have the vegetation, industrial, commercial, and residential area. For priority site 2, we have 3 areas: the city center, mixed industrial and commercial zone, and planned units of development, or PUD1. A total of 18 field samplings were conducted in Mandaue City. The parameters we collected were LST, or the temperature of the surface of materials, AT, or air temperature, which is the temperature of the air, relative humidity, the measure of water vapor in the air, and lastly, particulate matter, which is the measure of pollutants suspended in the air. To look into the effects of material type and color on LST, we did a field sampling last September 6, 2019. These are the different material types and colors we measured, from bare soil, grass, concrete, asphalt, and metals. The graph here shows the temporal trend of LST or the change of LST over time. LST started to increase during morning, peak during noon and early afternoon, then started to decrease during late afternoon. Bare soil has the highest LST since it is directly exposed to solar radiation. It is around 14 to 16 degrees hotter than soil with grass and bush. Vegetation like grass, bushes, trees, and mangroves play a significant role in reducing LST through the provision of shade that blocks solar radiation and through evapotranspiration that cools off the surroundings via evaporation of plant moisture. For concrete, we sampled 4 different colors. We got brown, gray, white, and yellow. Again, LST started to increase during morning, peak during noon, then started to decrease during late afternoon. The brown colored concrete has the highest LST of 58 degrees Celsius during 2 p.m. Dark colors tend to absorb more solar radiation, while light colors tend to reflect solar radiation. For asphalt, we have gray and white. The gray colored asphalt have higher LST compared to the white colored asphalt. It can be noted that the gray colored asphalt has a higher peak LST of 58.9 degrees Celsius during 2 p.m. compared to the brown concrete. For metals, we have sampled yellow, black, and blue. It can be observed that metal surfaces tend to heat up during morning. Metals tend to heat up fast and also cool down fast due to their innate heat conducting properties. The black colored metal has the highest peak LST of 62.4 degrees during 9 a.m. Lastly, tiles. Tiles are known to be highly reflective. That's why they have the lowest peak temperature of 50 degrees Celsius compared to the other urban materials. Again, a similar pattern was observed wherein dark colors, for example here, which is the brown colored tile, have higher LSTs. In this section, I will be discussing the results of our spatiotemporal variation analysis of LST. Here is the summary of our field samplings from April to December. We lack some data from the mangrove area due to some difficulties and restrictions. The graphs here show the temporal pattern of LST, wherein the LST starts to heat up during morning, peaks during afternoon, and starts to cool down during evening. However, there are also instances wherein the LST peak during morning, for example here, because of direct exposure to solar radiation. It can be observed that the vegetation area here has lower LST compared to the other areas, which are attributed to the urban impervious material composition of these three areas. A similar temporal pattern is observed in priority site 2. All sectors have mostly similar surface temperatures. However, there are cases wherein PUD1 have lower LSTs due to better air ventilation that could be attributed to it being open. In this section, I will be discussing the spatiotemporal variation of air temperature. A similar pattern can be observed here in air temperature. Air temperature started to increase during morning, peak during afternoon, and starts to cool down during evening. One key observation is that there are times when the residential area has the highest air temperatures. It is because of the poor ventilation, since the houses and buildings are densely packed together. In priority site 2, the same temporal pattern of air temperatures can be observed. In this section, I will be discussing the spatiotemporal variation of particulate matter. The vegetation area has the lowest PM concentrations compared to the other areas. On another note, the highest PM concentrations were observed during evening, as you can see here. It is because of the exhaust of many vehicles during rush hour traffic and exhaust from barbecue stands. A similar temporal pattern can be observed in priority site 2. In this section, I will show you the summary of our results using remote sensing data, Landsat 8. Remote sensing is the most commonly used approach. It is because it has a wider resolution from city blocks, cities, province, or a whole country. It is also less costly in terms of money, time, and physical effort. In this study, we utilized the GUHeat plugin using QGIS and Climate Engine. This is a graph showing the annual temporal trend of LST in Mandaue City from 1996 to 2019. Peak average surface temperatures were observed during the years of 2001, 2010, 2016, and 2019. A peak surface temperature of 26.7 degrees Celsius was observed during 2001, while a peak surface temperature of 29 degrees Celsius was observed during 2019. These are the results of our analysis. The left figure is the Mandaue city map with its barangay boundaries, while the right figure is an example of an LST map during March 23, 2020. areas that have high LST, for example, this place and this place, are the heavily built up areas here. Areas with vegetation and mangroves are the areas with low LSTs. In order to further our analysis in a barangay level, we did hotspot and cold spot detection. Hotspots are high LST areas, while cold spots are low LST areas. Few examples are Barangay Tipolo as a hotspot. As you can see here, Barangay Tipolo is highly urbanized, while Barangay Casili is considered as a hotspot, which is very highly vegetative. This is the summary of the hotspot and cold spot detection. Highly built up barangays, for example, Barangay Tipolo, Barangay Bakilid, Barangay Ibabaw Estancia, have higher number of hotspot pixels, while vegetated barangays like Barangay Casili and Tawason have higher number of cold spot pixels. There are also areas with mixed pixels due to the variations in composition. So actually, if you want to know more in detail regarding our study, this study was presented last year in the PhilGeos GeoAdvances conference. It is published in the International Society for Photogrammetry and Remote Sensing, or ISPRS archives. You can check this scientific article using this DOI link. To summarize the study, here are the key findings and our recommendations based on the research. First, using spatial and temporal analysis of LST, it was determined that urban heat island phenomenon occurs in Mandaue City. Built-up barangays are determined as hotspots, while vegetated barangays are determined as cold spots. Commercial, industrial, and residential areas tend to have higher LSTs and ETs due to the presence of impervious urban materials, while the vegetative areas have lower LSTs and ATs due to the presence of trees and shrubs. The color variation of surface materials have a large effect on LST. Light-colored materials have lower LSTs compared to the dark-colored materials that have higher LSTs. For our recommendations, urban planning must include UHI mitigation strategies such as greenification of urban spaces, and also use of light-colored surfaces to promote more efficient emission of solar energy. That's the end of my first presentation. Thank you for listening.